Hello everybody and welcome. Today we are introducing another very important type of force, which is friction. So please concentrate, this video is very important. Now, first of all, we need to introduce what friction is. So friction is simply the force that resists the motion between two objects that are in contact with each other. So in other words, if these two objects are not in contact, there will be no friction between them. Now, imagine you're trying to push a box on the floor. Well, it won't move smoothly because of this friction force. Now, you may look at the table and say, no, the table looks smooth. There's no friction. Why is there friction while the table is smooth? Well, actually, friction occurs because there are very tiny bumps and roughnesses, even though if they appear smooth. So let's look at this box right here. It's in contact with a surface. If we can look through a microscope or through a very strong lens, we can see that these two surfaces have these very small tiny bumps, as you can see, between these two surfaces. Now these are what cause friction. Now let's say that the direction of motion, you're trying to push the box to the right, we will know for sure that the friction will go in the opposite direction. So friction is always opposite to the direction of motion. It is a type of force. Now friction depends on two main factors. First of all, the roughness of the surface. So the more rough the surface is, the more the friction is. And I think that's very common sense. Now, we will be using the term coefficient of friction. We will not be saying the roughness of the surface. We're going to call it the coefficient of friction. So the higher the coefficient of friction, the higher the roughness of the surface. Now, the value of the coefficient of friction is always between 0 and 1. It's a fraction. It's never more than 1. It's never smaller than 0. So it's always a fraction. And as we mentioned, the higher the value, the rougher the surface. And finally, the normal force the surface exerts on the object is another factor that the friction depends on. So we introduced normal force before. Remember when we said that we have a surface and this surface is on a horizontal, this object is on a horizontal surface. We know that the weight in this case will be equal to the normal. So that's why we introduced the normal. It's very important to be able to calculate the normal so you can calculate the friction. Is there a relationship between them? Well, actually, yes. What is this relation? First of all, we must introduce the two types of friction. The first type of friction is called the static friction. In other words, sometimes you try to push an object, you're applying a force, but this force is not strong enough to beat this friction. And since you're not strong enough to beat this friction, we can say that the friction force is there, but we call it static friction. So when the force applied on the object is less than the friction force, we call this static friction. In this case, we will use something called the static coefficient of friction. Now this mu, this is the symbol called mu. We call it the coefficient of friction. Now there are two types of coefficient of friction. The first one is called the static coefficient of friction. The other type, we will introduce it right now. The other type of friction, it's called the kinetic friction. In other words, when the force you applied now, it's stronger than the friction force. So now the object starts moving. There's kinetic motion. When you push the object and it starts moving, that doesn't mean that the friction isn't there anymore. It's there, but the force you applied is now stronger than the friction. And this will change the friction force. In other words, you're trying to push the object, you're applying a force, it's not enough. So this is static friction. Now you increase the force and the object starts moving. Yes, the friction is there, but the value of friction now changes. And in this case, we will use something called the kinetic coefficient of friction, mu k. Now we have here mu s for static, and here we have mu k. What is the mu? Mu is this symbol. It's a Greek letter. Mu, we introduced it before. Actually, we've seen it before. Now a very important note. Each surface has a static and a kinetic coefficient of friction. For the same surface, it will have a static coefficient of friction and will have a kinetic coefficient of friction. Now, one of these values will be used depending on the state of the object on the surface. So, if you're applying a force and the object is not moving because the static or the friction is stronger than the force, we can say that here we will use the static coefficient of friction. But if you apply a force that is strong enough to beat the static coefficient of friction, in this case we will use the kinetic coefficient of friction. Now, the equation used to find friction, actually it's very, very straightforward and easy. We've been talking a lot about friction, but the equation is very straightforward. Friction force, we normally use the small f, is simply mu multiplied by the normal force. Okay, but which mu should we use? Should we use the static or the kinetic? Again, we could go back to our note here. If the object is moving, we can say that we are using the kinetic coefficient of friction. But if the force is not strong enough to move the object, we will be using the static coefficient of friction. I hope that is clear. So simply, friction is a force and it has a unit of N. The coefficient of friction has no unit, it's unitless. And finally, the normal force, it is simply a force and it has a unit of N, also newtons. So let's introduce some examples. Let's say that a book that has a mass of 1 kilogram is set on a horizontal table, okay? Horizontal table. Again, it's important to know the situation of the surface. Why is that important? Well, if you go to the previous video, the normal force depends on the state of the surface. If the surface is horizontal, we can find the normal force in a certain way, but if the surface is now inclined, the normal force will have a different value. We will be introducing it right now in an example. Now, it has the following coefficients of friction. It has mu k, which is the kinetic coefficient of friction, and us, which is the static coefficient of friction. Now, it says here that a man tries to push this book. The book has a mass, again, of 1 kilogram, okay? Increasing the force, or he keeps on increasing the force until the book starts moving. So at the beginning, he applies a force. It's not moving, okay? Keep that in mind. Now, he keeps on increasing the force until the object starts moving. Now, first question, what is the force that is applied by the man on the book just before it starts moving? In other words, it is not moving. Okay, since it's not moving, which coefficient of friction shall we use? Exactly, we will be using the static coefficient of friction, so we can say it is static. In other words, we will be using mu s because it's static. Now, he's asking about the force applied by the man on the book just before it starts moving. Well, we know that here, this is the book. It's on a horizontal surface. There's the force applied on this object. And what's stopping it from moving is the friction force, okay? So we agree on that since the object is trying to go this way, the friction is going to push the other way, or it's going to pull the other way. So we can for sure say that the object is not moving yet. I can simply say that the force the man is applying must be equal to the friction force because he's not moving the object. So we can say that simply the force the man is applying, it will be equal to the friction force. We can say that the friction is simply equal to mu s in our state because it's a static coefficient of friction multiplied by the normal force. Okay, what is the normal force? Since the object is on a horizontal surface, we can say that the weight is pointing this way, and we can say that the force will be, or the normal force will be equal to the weight because it's a horizontal surface. Now, friction will be simply equal to 0.35 multiplied by the normal force, which is the weight, and we know that weight is equal to m multiplied by g. Okay, so we can simply say that the force is equal to 0.35 multiplied by the mass, which is 1 multiplied by 9.8, and you can find the value yourself. Okay, so when the man is pushing the object and it's not moving, we can say that the force is equal to the friction. Now, the second part, it says, now the book is moving. Okay, so the book started moving. How much force does the man have to maintain on the book to keep it moving at a constant speed? Okay, this word constant speed has a very important meaning. We will be talking about it in very much detail in the next videos when we start solving dynamics problems. Until now, we didn't solve any dynamics problems. So, we know now that the object started moving, or the book started moving, and it's on a horizontal surface. Now this is the force, and this is the friction that is pointing in the other way. I can say again that since it's moving at a constant speed, in other words, there's no acceleration, don't mind what I'm going to say right now, but I can also say that this force again is equal to the friction force because we only have these two forces. But this time the object is moving. So the object is moving, and we will be using in this case mu k, which is the kinetic coefficient of friction. So this force is going to be equal to the friction force, which is simply mu k multiplied by the normal force, and we here have 0.25 multiplied by 1 multiplied by 9.8. Okay, what's very important here is that this value is smaller than this value. Well, how did you know that? Well, it's all the same numbers except the coefficient of friction. Here it's 0.35, here it's 0.25. So I know for sure that always the kinetic friction is always less than the static friction. Please keep that in mind. Next example. It says here that a 10 kilogram box is at rest on a surface. So the box is not moving. It's on rest. On a surface, a force of 20 newtons is needed to start the motion. So it's not moving yet. It's just the force needed is 20 newtons. What is the coefficient of static friction? Again, because it's not moving, between the surface and the box. Well, let's draw it right here. This is the box. This is our surface. The force applied is equal to 20 newtons. And here we have friction and it's not moving. So I can say that the friction here is equal to mu s multiplied by the normal force. Okay. Now, I do not have the coefficient of friction, but I can for sure say that this friction force will be equal to the applied force because these forces cancel each other and the object is not moving. What is the applied force? It's equal to 20 newtons. So I can say that the friction force is equal to 20 newtons, and I can go back to my equation. So I can say here 20 is equal to the coefficient of friction, which is unknown, multiplied by the normal force. Now, is the surface horizontal? Yes, as we can see, the surface is horizontal. So I can say that the normal force is equal to the weight, which is m multiplied by g. Again, so 20 is equal to the coefficient of friction, which is unknown, multiplied by the mass of the object, which is equal to 10 kilograms, multiplied by the weight, which is 9.8. Sorry, multiplied by g, which is 9.8. So I can say that the coefficient of static friction is simply, I will divide both sides by 10 multiplied by 9.8, and I will divide here by 10 multiplied by 9.8. So I can simply say that the coefficient of friction is equal to 20 divided by 98, which is approximately 0.2, which is the coefficient of friction. Now, it's very important. If you see that the coefficient of friction is larger than 1, there's a problem with your answer. Let's see more questions. Here it says that a block is sliding down a plane inclined surface. So the inclined surface is at 8 degrees with the horizontal as shown next. The angle is now increased. As you can see, we are increasing the angle here. The coefficient of kinetic friction between the bottom surface of the block and the surface in this case will, again, so let's try to introduce this question. Now we had a small inclination angle. Now we increased this inclination angle. What will happen to the coefficient of kinetic friction? Well, actually, the answer is nothing. Nothing will happen to the coefficient of kinetic friction because the coefficient depends on the surface itself. It doesn't depend on the inclination angle. So coefficient of friction does not change if we change the inclination angle. Another question, it says that a 15 kilogram crate initially at rest on horizontal floor requires 60 newtons of force to move it. Determine the coefficient of static friction between the crate and the floor. Actually, we solved a question that is similar to this one before. So this is the object. It's on this surface. A force that is 60 newtons is applied on it, and it is at rest. So we can say that this force will be equal to the friction force that it's applied. So force will be equal to the friction. So we can say that the friction force is 60 newtons. Now we know that friction, it's equal to mu s multiplied by n. Why did we use s? Because it is at rest. So 60 is equal to mu s multiplied by the normal force. What's the normal force? Because the surface is horizontal, this is the weight, and this is the normal. They will be equal to each other. So it's multiplied by mg. M is equal to 15 multiplied by 9.8. So we can simply say that ms, or the mu s, sorry, it's equal to 60 divided by 15 multiplied by 9.8. And the answer in this case will be equal to 0.25. Well, actually, you can look here. C and D are impossible because they are bigger than 1. Imagine you have a question where this is not 0.41. Let's say this is equal to 4.1. You don't need to solve anything. All of these are larger than 1, so we can cancel them and we can just go with choice A. But since we have two choices that are less than 1, we needed to solve this problem. Okay? So now we introduced a lot of forces. We introduced the weight, we introduced tension, we introduced friction, we introduced normal, and we introduced most of the types of forces that we need to solve dynamics problems. To solve dynamics problems, please stay tuned in the next videos. They are very important. See you then.